Hello, this is going to be step 3 in our second project. What we did in step 1 is run regressions to estimate our alphas, our standard errors, our betas, our standard errors, and standard error equations. And we also output the residuals. So what we're going to do now is create our forecast beta. First step, create the forecast beta. We want to calculate the average of all the betas that we have, and then the standard deviation of all the betas that we have. And then we're going to apply Vissic's methodology, which is on page 146 of the text and the 8th edition. And that's what we've done down here. I'll double click on this first one to show you the equation. We're taking the standard error of the beta estimate and we're squaring it. We're dividing it by the sum of the standard error squared and the standard deviation of the population squared. So these are two variances. This is a variance. And then we're multiplying that by the average beta of the portfolio. We add to that the standard deviation squared of my betas and divide that by the total of the standard deviations. This standard error squared plus a standard deviation squared, and we multiply that by the beta for the actual stock. Once you've got that equation in and you're sure you have it correct, you'll just click and go ahead and drag it down. Now notice here that we've dollar signed so that this doesn't change, and dollar sign so that this doesn't change. So the variance of the standard deviation of the population of betas and the mean of the population of betas shouldn't change. Alright, so that's your first step. Now these are what are called the forecast betas. These are what we expect the betas to be over the next year, the next period that we're interested in. Step 2, we want to generate the variance-covariance matrix of the residuals. We come here to our residuals tab. Here are the companies, here are the residuals that we created before. We'll come into data, data analysis, and we're looking for the covariance, which is what we did in the first project. We're going to go ahead and highlight our section residuals, and then labels in the first row. Collect our output range. In this case, we're going to go back to our betas. I'm just going to dump it right here. Go ahead and calculate it. So this is the variance covariance of our residuals. The variance on the diagonal, the covariance is here, and all the off diagonal positions. Just as we did before, we want to highlight and copy and then use the transpose function to create a square matrix. I'm going to go ahead and delete this. We already have it done. So this is my variance covariance matrix. So our next step is then to calculate the market variance. I'm using the var .s, which is the variance dot of the sample. So you do an equals var .s, and then we'll come over here to our returns and highlight our returns of the market, the variance of the market. So we have our variance covariance matrix for the residuals, the variance of the market. Now it's time to calculate the stock variance covariance matrix. So on the diagonal, the variance of the stock is the beta of that stock squared times the variance of the market plus the variance of the error term. So here we have the beta of IBM multiplied by H17, notice the dollar signs, which is the variance of the market, multiplied by the beta of IBM, and then we're going to add the variance of the residuals. Those are going to be the ones on the diagonal. And just as we did before, your first step would be, just as a reminder, so this one is going to remain constant, this one's going to vary. We have our equation in there, we go ahead and drag it across, and then we come back and we change this one so it's going to vary all the way, and this one so it's not, and we do that on the way across. And my last one. And then we'll highlight here and go ahead and drag down. I'll add my line back in just to keep things nice and organized. Alright, so this becomes the variance covariance matrix that we're going to use for our Sharp Optimal portfolio. As I've shown you before in some of the other videos, you want to copy over one of your worksheets from your first project, just so that you have all the equations and everything set up nice and neatly. The beta of our stock, we're coming here, for example, we would just say this is equal to, come over here to our betas and select the beta of IBM, and then we just drag that down. Expected return is a little bit different here. We're not using the capital asset pricing model, we're using this known as the market model. You'll notice that we calculated our alphas. These are monthly alphas, in other words, the excess return per month. In expectation, our guess about the future, however, has alpha equal to 0, right? In the long run, alpha is equal to 0. Since we're forming this portfolio for at least a year, maybe multiple years, what I do is I assume that alpha is just going to equal to 0. We don't apply it into the equation. In addition, stocks tend to move from undervalued to overvalued to correctly valued to undervalued to overvalued. That's where this alpha is kind of, what this alpha is kind of picking up. So we're going to assume in the future that everything is pretty much correctly valued. So in that case, we're not applying the alpha. All we do is we take the beta of the stock and we multiply it by the market return. This is part of the art of finance, not necessarily part of the math of finance. Whether you include alpha or not is up to you. Just explain why you did or didn't. For example, this is 2.4% per year or per month. So over 10 months, it's 24%. That's just ridiculously high. So I'm not including alpha. And these three alphas are not statistically different from 0. So having 0 in there is not a problem. This one's a little high, 1.4%. Again, 14% in 10 months of excess return. And a little excessive. So back to our sheet, we're just using the stock beta multiplied by the market return. And then our weights are going to come from our optimization. I'll go ahead and change these 5%, 30%, 30%, and 30%. So we're at 100%. I don't know why my screen keeps screwing up on that. In order to get the variance covariance matrix that we're interested in, we'll just come here and we're going to set that equal to, come over to my beta sheet, click on the first item, and then we'll go ahead and drag this across, and we'll go ahead and drag it down as well. And here's our variance covariance matrix, just like we had before. As long as this is in line, your weighting matrix is going to come up exactly like it was before. So my weight, right, my weight multiplied by my standard deviation multiplied by my weight, and as you go across, that's going to be the same. Right? So on this last one is weight. So you shouldn't have to, as long as you judiciously place everything correctly, you should be in fine shape. We sum each column just as before, and then we sum across. This is the standard deviation of the portfolio. Sorry, this is the variance of the portfolio per month. We multiply that by 12, and then take the square root of everything. Our annual return is just the sum of our contributions. Our Sharpe ratio stays the same. It is the annual return minus the risk-free rate quantity divided by the annual volatility, and we're going to have the leverage set at 0. Since I copied this over from my other worksheet, I can go back to data and the solver. All my constraints remain the same. My optimization function remains the same, and we go ahead and solve it. And there we go. So these are the weights based on this weighting matrix and based on the market model for expected returns. And we can compare that to our Sharpe optimal portfolio from the first project. This is mine. 5% on IBM, 5% on P&G, 55% on DuPont, and 16 point, as you see the numbers here. Total 100%. Expected return of the portfolio 12.64. Annual volatility 21%. Sharpe ratio of 5.93. Now, one of the things is you cannot compare my first Sharpe optimal portfolio with my second Sharpe optimal portfolio because I'm using a different covariance matrix and a different model in order to assess it. In other words, just because this one has a higher Sharpe ratio does not necessarily mean that it is the better portfolio. This one has a lower one. Our question here is to try and create a better forecast of the future, a better crystal ball. So if this methodology works better than the error or the mistake between what I expect to earn, which in this case is 9.2% per year, and what I actually earn should be significantly smaller than on my Sharpe optimal portfolio. And that's also part of this particular assignment. You'll have to assess your year-to-date return based on these weights and how well your model predicted what the future was going to be. All right, so that is the process. The next step that we're going to do in a separate video is to use the Fama and French 3-factor model. It's slightly more complicated, so we'll go on to that one. Thank you.